Now let's look at some more. We've already done G, H, and I. Let's look at J. For J, notice we've got two different kinds of roots. We've got a fourth root and a cube root. They can't do anything together. They can't be brought together because they're two completely different kinds of roots. So the question becomes, can I turn them into the same type of thing? And yes, you can. If you remember that roots will just go into the bottom of a fractional exponent. Then they'll both have just fractional exponents. That means we'll have x to the, well, again, the root goes on the bottom. So if it's a fourth root like it is here on top, that 4 will go on the bottom. Remember the x here, you don't see it, but it's a hidden 1. So it's x to the first power goes on top. Now let's look at what the bottom will turn into. Well, we'll have an x on the bottom, and what kind of root's on the bottom? It's a cube root. So that means on its fractional exponent, there will be a 3 on the bottom. And again, what's hidden on that x on the bottom is a 1, so it's to the 1/3. Now, this does actually help you because you still at least have the same base. The bases are both x's, so that will stay the same. The question is, what do you do to your exponents? Well, when you're dividing, you take your two exponents and subtract. So I have a 1/4 on top minus the 1/3 on the bottom. Well, in order to subtract two fractions, I need a common denominator, which in this case will be 12 between 4 and 3. So the first fraction needs to get multiplied by 3. That will give me 3 on top. The second fraction needs to get multiplied by 4 to get the 12, which will give me a 4 on top. Now, because I have a common denominator now, I can subtract. Well, the 3 minus 4 will get me a negative 1/12. So as of right now, I have an x to the negative 1/12. There is only one issue with this problem and this answer here is that we can't leave it with a negative exponent. So what do we do with that then? To get rid of the negative exponent, we drop it down to the denominator. So it'll become x to the positive 1/12 when you drop it down to the denominator with a hidden 1 on top. And again, you're fine leaving it like that, but here's one big catch. If you started out with roots like you did in this problem, you should probably turn your answer into roots as well. So what can you do to rewrite your answer? As a root, remember that the root is on the bottom, so that's a 12th root of what? It's an x inside, and there's a 1 on the outside, so an x to the first power, or just an x. And again, remember it was on the bottom because it originally had a negative exponent after subtracting. So our answer that we'd like to give is 1 over the 12th root of x. Next, let's look at k. K is very similar. On k, we have the 5th root of x cubed over the 6th root of x squared. So again, what we would like to do is turn them into the same type of thing. Right now, they're completely different roots. So the question is, can I turn them both into just regular exponents? And you can. So on the first one on top, we've got a 3 and a 5. Remember, the root is what goes on the bottom. So the 5 goes on the bottom. The 3 goes on top. And on the denominator, we have a 2 and a 6. So again, the root goes on the bottom. So the 6 will go on the bottom. The 2 will go on top. Now you've got the same base, but you're dividing two things with the same base. So what do you do to the exponents? You subtract. So we've got a 3/5 minus a 2/6. So I need a common denominator of 30. Well, to get a common denominator of 30, the first fraction has to get multiplied by a 6, which will give me an 18 on top. The second fraction, however, to get the 30 will be multiplied by 5 on the bottom and top, which will give me a 10 on top of the 30. Now you have a common denominator, so you can go ahead and subtract, though, at least. The denominator will stay the same, and on top we've got an 18 minus a 10, which will be 8. Again, that's not a reduced fraction, so I need to reduce that. Well, 8 over 30, those are both divisible by, let's see, 2, which if you reduce them both by 2, that will turn this into a 4 over 15. So what that gives me right now is that once I subtract my exponents, I get x to the 4 over 15. Now, that's a good answer because it's a positive exponent. The only thing that we might want to do is, again, we started out with roots. As our original problem, there were roots. So we should probably give our final answer with roots. So remember that the denominator tells you what kind of root you have. In this case, it was a 15. So that tells us we can turn this into the 15th root of what? Well, we've got an x and a regular exponent of 4. So this would be a 15th root of x to the 4. That would be your final answer. 15th root of x to the 4. Last problem. Let's look at L on the next page by itself. L is the square root of x times the cube root of x. So we want to take the same tactic. You can't multiply two roots if they're different kinds of roots. So we want to rewrite the roots and see if that'll help us. Well, let's take a look at the square root first. Well, a square root means you have a hidden 2. So if you're going to rewrite a square root as a fractional exponent, it means you'll have a hidden 2 out there. So a hidden 2 will go on the bottom. Remember, the hidden exponent on the x is a 1 if you don't see anything. So it'll be x to the 1/2 times, for your second root, you have a cube root. So that means that on the denominator, because again the root goes on the bottom, will be a 3. Again, I don't see an ordinary exponent, so it's a hidden 1, so 1/3. Now the bases match, and I can just deal with exponents. They both have a base of x, so that will stay the same. Then I do what to the exponents? Well, when you're multiplying, you add exponents. So I'm going to take the 1/2 and add the 1/3 because we're multiplying, we add exponents. So 1/2 added to 1/3. Well, if you're adding fractions, I need a common denominator. What's the common denominator between 2 and 3? It's going to be 6. So that means the first fraction here is going to need to get multiplied by a 3 to get the 6, which will give me a 3 on top. The second fraction is going to need to get multiplied by 2 to get the 6, which will give you a 2 on top. So then adding and subtracting normally, the 3/6 added to the 2/6 will give me a 5/6. So that gives me that when I combine my two roots as fractional exponents, I get an x to the 5/6. Again, you started with roots. Let's make sure we have a root as our final answer. Well, the denominator tells us what kind of root we have. We have a 6 on the denominator, so we're going to have a 6th root of what? Well, we have an x to the 5th here. So it's the 6th root of x to the 5th. And we are done. That's it.